I will speak about the new architecture, but let's start by the current architecture. So I will explain what we currently have, and then we will see what we wanted to improve. I will show you the new architecture. So this is what we currently have. We have a cluster admission policy resource, which you can create with kubectl or the API client. And once you create it, we have a Kubewarden controller, which is watching this resource. It watches the resource. This resource contains information about the webhook configuration and the policies itself. The policies are WebAssembly module. The controller creates the webhook configuration and also attach the policy inside the policy server and do a rollout. I won't go into further detail about the policy server, how the policy server works, because it's out of the scope for this presentation. But as you can see here, we have just one policy server deployment. We can have many replicas, but each replica must load all the policies. So imagine you have 20 policies and 10 policy server replicas. All of the 10 instances must have the 20 policies there. So now let's move on to what do we want to improve. So the first thing is scalability. As I mentioned, all the policies needs to be loaded, but each process. So we want to find a way to partition the policies, not just for scalability, also for priority as well. Imagine you have a mission critical policy and you want one server just doing this. You don't want to have all the policies in the same place because maybe one is very important and you want to keep one server just there, and no one should be allowed to publish any other policy there. And also, we wanted to provide an easier way to update the configuration of the policy server deployment. Currently, you can do that. You can go and edit the config map, but we wanted to provide an easier way of doing this. Okay, so now let's move on to the new architecture. As you can see here, now we have another resource, which is the policy server. And also the Kubewarden controller is watching the events that happens in the policy server, creation, modification, deletions. And it's also watching the cluster admission policy. So it's watching both at the same time. And now it's creating the policy server, but now you can have several policy servers. So you can have whatever you want, the number of policy servers, and each policy server can have different policies. So now you can divide the policies between different servers. Okay, so now let's see an example of these new resources. This is the new one, the policy server. You can see here you have a name, and then you have the image, the replicas, and these two parameters, which are optional if you want to add variables or annotations. And as I mentioned earlier, we wanted to provide an easier way of changing this. So now you have this resource. You can easily change the replica or add a new annotation if you want here. And we modified the existing resource we had, which was the cluster admission policy. So now you can add a policy server. So here you have this field, and you can provide the name of the policy server you want this policy to be bounded to. Okay, a few things to keep in mind. It's we are providing a default policy server. So when you install Kubewarden, you will already have one default policy server. And if you don't put a name, a policy server name, in a cluster admission policy, by default, it will be attached to this default policy server. So if you want to use Kubewarden as you were using it before with just one policy server, that's fine. It will work as it is working right now. One limitation is we don't allow to change the name of the policy server. Once you attach a policy to one server, you cannot just change it. You can always remove it and then attach it to a different one. And also, if you create a cluster admission policy and attach it to a server that does not exist, this policy will never be created. It will be unschedulable until you create the policy server. So it will be like an appending state. Another thing we added was a finalizer. We are doing this using a mutating webhook, so users don't have to manually add a finalizer. But we did that to get it in control of a Kubernetes garbage collection. We didn't want a resource to be deleted when our controller was not available or something, because then our controller, when he was up again, he could not see this change. So we added a finalizer. That means that when you delete an object, Kubernetes will not delete it itself. It will just mark it as pending for deletion. And then we do the logic in our controller to do the things we want. And then from the controller, we remove the finalizer, and then the resource is finally removed.